we have seen how to sort the elements of a collection of list string. Okay, we can sort collection of a list string, okay, by making use of a sort method which takes a list or which takes a list as well as a comparator. If you want to sort a list using a sort method which takes a list, okay, then what we do is we should implement that base object with comparable, and we should override comparator method. Okay, and if you want to sort a list using list and comparator, then we should write a comparator. In general, we write a comparator by making use of an anonymous net class. Okay, that's what we had discussed in the previous class. In the current class, we will see how we can sort the elements of a set. Sorting the elements in a set.
All collection everything are in Java or
Yes.
so then how do you compare it in Java or Pascal?
See, comparable, it's used in collections, but it is not a specific property of collection. It's the generic property of all the entities. Any entity that is supposed to be comparable should be comparable. So, are we making a specific entity or the base entity as comparable? So, a base entity can be any class. So, in general, if you are making any accessing for the base entity, then we keep that in Java long package. For that reason, we keep wait and notify all in the object class. Okay. Now, let's see how to sort the elements of a set stream. Either in list stream or set stream. If you want to sort the elements, then the elements should be mutually comparable. Otherwise, we cannot sort the elements. Okay? Either in a list stream or a set stream, if you want to sort the elements should be mutually comparable. Okay? Now, what are the implementation classes that we have seen in set stream? Right now, up to now, what are the implementations of the set stream that we have discussed? What are the implementations of set stream that we have discussed right now? Asset? Linked asset. What is the third one? Third one is tree set, which is not a direct subclass to set. Okay, tree set is a subclass to sorted set, and sorted set is a subinterface to set. Okay, ultimately, and last one is tree set. Okay, and this tree set is used to sort the elements in a collection, in a set stream. In a set stream, if we want to sort the elements, then we should go for a tree set. These are the elements that I have added to a set. Okay, now the set is pointing to a tree set. We have added some elements to a set. Now set is pointing to a tree set. Now the set is pointing to a tree set. So I'm adding some elements to the tree set. Okay, and let us see how it happens. 200, 50 and 115. So I'm adding some elements to the tree set. Okay, let us see what happens. So now, what is the order that I have inserted? 200, 123, 50 and 115. What is the order it is being displayed? Is there any specific order? It's in the ascending order. So the tree set elements will be automatically sorted. Okay, the elements of the tree set will be automatically sorted. And how we can sort the elements of a set stream means just we should go for a tree set. If we want to go for a sorted set, definitely the only option that we have is tree set. If you want to go for a sorted set, definitely we should go for a tree set. And if you want to sort the elements, how the elements should be? If you want to sort the elements, how the elements should be? The elements should be mutually comparable. As I told many times yesterday, if you want to sort the elements in any stream, either list or set or map, if you want to sort the elements should be mutually comparable. Okay? So now, are these elements mutually comparable? 200, 123, 50 and 115? Yes or no? Yes. These elements are mutually comparable. So we can sort the elements. Now, what would be the size of the set? Will tree set eliminate duplicates? I told that tree set will sort the elements, but will tree set eliminate the duplicates? Will tree set eliminate the duplicates? Definitely yes. Just because duplicate elimination is for the whole set stream. Any collection class that is present in the set stream will eliminate the duplicates, either hash set or linked hash set or even tree set. Any collection class that exists in the set stream will definitely eliminate the duplicates, either hash set or linked hash set or even tree set. So even tree set will eliminate the duplicates. Duplicate elimination is a property for the whole set stream. So any collection class that is present in the set stream will eliminate the duplicates. There is no question whether tree set will eliminate duplicates or not, because if it is a set, definitely the first property is to eliminate the duplicates. Yes, I'm trying to compile the application. Go to the classes, execute the application. So, are the duplicates eliminated? Duplicates are eliminated as well as sorting is happened. And sorting automatically is a specific characteristic of tree set. It's not present in hash set or linked hash set. Sorting the elements automatically is a characteristic which is specific to tree set. That doesn't exist in hash set and linked hash set. Okay? Now, can we add null values to a tree set? Can we add null values to a tree set? This is my question. Can we add, just think it practically, can we add null values to a tree set? Yes or no? Is it possible to add null values to a tree set? Just think and tell. Is it possible to add null values to a tree set? No? No. Why? Why we should not add null values to a tree set? Since tree set elements are automatically sorted, if we want to sort the elements, then the elements should be mutually comparable. Then, see, if we add null values, definitely it will give a null pointer exception while comparing. So, nulls are not allowed in tree set. But the compiler will not give any error. Compiler will not give any error if we add null values to a tree set. But at the runtime it will give a null pointer exception. Compiler will not give any error. But at the runtime it will give a runtime exception. So, the compiler will compile successfully even if we add null values to a tree set. Okay? Did we add? No. Let me add null values to a tree set. The compiler will not give any compile time error even if we add null values to a tree set. Okay? But at the runtime, so the compiler is compiling successful even if we added null values to a tree set. But, sorry. If we try to execute the application, then it is giving a null pointer exception. So, we should not add null values to a tree set. If we try to add null values to a tree set, then it will give null pointer exception. But, will it give null pointer exception if we add null values to a hash set or linked hash set? Will it give a null pointer exception if we add null values to a hash set or linked hash set? No, only for a tree set, null values are not allowed just because there is automatic sorting and null value is not comparable. And now, what will happen? What could be the size of this set? Elements are? All of you agree with that? All of you agree that elements are non-comparable? Integer? Why integer will be treated as double? Why do you think? Just I am trying to clarify you. Why do you think that integer will be treated as double? Integer will be treated as integer and double will be treated as double. Why did you think? That's what my question. Why did you think that integer will be treated as double? Now, what happens? All of you agree that these elements are not mutually comparable? Or is there any other answer? Just speak out. Are these elements mutually comparable or not? What is giving? Classcast exception. If the classcast exception occurs at the runtime while sorting, what does it mean? If the classcast exception occurs at the runtime, what does it mean while sorting? Some of the elements are not mutually comparable. Okay? Why the elements are not mutually comparable means? What is 200? What is the data type of 200? Int, a primitive int. How it will be added to a set? How it will be added to a set? It will be boxed into an integer wrapper class object, and that integer wrapper class object will be added to a set. And now how it will be added to a set? A double wrapper class object. Now, are a double wrapper class object and integer wrapper class object same? No, those two are different. So, since those two are different, those two are not mutually comparable. So, for that reason, this is a classcast exception. Okay. Now, some of the jurors will, in some of the written tests, they will give 4 options: compile time error, runtime exception, size is 4 or size is 7, something like that. Okay. You should give a correct answer. This will be a exception at the runtime, which is classcast exception, just because the elements that are present in a set are not mutually comparable. Just because the first one is integer wrapper class object that is added into a set, the second one is a double wrapper class object that is added into a set. So if you are adding primitives, means primitives will not be added to a collection. The primitives will be boxed into the corresponding wrapper class objects, and that wrapper class objects will be added to the collection. So 200 will not be added. The integer wrapper class object whose content is 200 will be added to the collection. A double wrapper class object whose content is 200.00 will be added to the collection. Okay? The corresponding wrapper class objects will be added to the collection if we try to add primitives to a collection. That we have discussed in the first class. Collections cannot hold primitives. Okay? Because of auto boxing, the primitive values are converted to corresponding wrapper class object, and the converted wrapper class objects are added to the collection. What, Prasad, getting sleep? No? If you want, you can wash your face. Okay. So as I told many times, okay, integer and wrapper class is completely different. It's not, both are not the same. And collections cannot hold primitives. Collections can hold only objects. So auto boxing happens here, and the corresponding primitive value will be converted into wrapper class object, and after the conversion the converted wrapper class object will be added to the collection, not the primitive. It's a very important thing and you need to keep it in mind. So if you want to add some elements to a tree set, okay, while adding itself, okay, the runtime environment will check whether the elements are mutually comparable or not. If the elements that we are adding are not mutually comparable, then at the runtime it will give a class cast exception. Okay, while sorting any collection, if the elements are not mutually comparable, then it will give a class cast exception at the runtime. Okay, so why class cast exception occurs means, okay, some of the interviewers will be asking like why class cast exception occurs. Just because 200 is there, which is an integer wrapper class object. 200.00 is there, which is a double wrapper class object. So first, if the object is supposed to be compared, then the object should be typecasted into the corresponding type. So 200.00 should be converted into integer, but 200.00 is a double which cannot be typecasted into integer. So first what we will do in the comparator method, we will typecast into our object. But while typecasting into the object of integer type, but the object is of type double. We cannot typecast double object into integer, so there itself we get a class cast exception. Okay, in the comparator method, how we will write the logic? We will try to try to typecast into the specific class. Okay, but what happens? The inputted one is double. Since the inputted one is double, in the integer wrapper class object, what happens? You will try to typecast into integer, but the inputted one is double. So there a conflict occurs where we are trying to typecast double into integer. Okay, can we typecast a double wrapper class object into integer wrapper class object? No. So because of that reason, it is a class cast exception at the runtime. Okay, understood why a class cast exception occurs while performing sorting with non-comparable elements? Understood? Understood, or do we need to discuss again? Yes? Do we need to discuss again? See, yes or no in communication will lead to many mistakes. Okay? So the question will be changing, might be changing from second to second. When I am repeating the question, okay, in any formal communication, a single word answer will lead to big mistakes, big confusions. Okay? I am asking whether you understood or not. And again I am asking whether there is a confusion or not. You did not, some people did not listen to my second question and they are telling yes. So, yes or no, just a word will make a big confusion. Is there any confusion means yes or no? What is your assumption? Yes means there is a confusion, or yes means you got an understanding. So, it will cause a big confusion in communication. So, in communication, words are not important, sentences. You should use proper sentences. Yes, I understood. Yes, there is a confusion. That should be used in communication. Okay? And whenever a new element is added to a tree set, it will be compared against to all the elements. let's consider like I have 5 elements. Let's consider like there are 5 elements in the set. There are 5 elements in the set. If we are adding 6th element, what happens? The 6th element, the newly added element, will be compared against to all the elements. This 187 will be compared against to all the elements that are present in the set. So let's consider like at present, let's consider like very initially we have 100. So sorry, 200, and again we are adding 123. So 200 will be compared with 123, okay, and some kind of shuffling happens, okay, and at present we have 123 and 200. Again we are adding 50. Okay, if we are adding 50 means again 200, the newly added element 50 will be compared against all the elements present in the tree set. It will be compared with 200 as well as it will be compared with 123. Okay, and if you are adding again another element. Now, first before comparing the elements, first duplicate elimination happens. First, if we are trying to add a new element to a tree set, first the tree set will verify whether the elements are duplicate or not. Are the elements duplicated here? Yes. Since the elements are duplicated, first the duplicate elimination will be done, and then sorting will happen. Okay, if we are trying to add new element to the tree set, first duplicate elimination will be done. Duplicate check and duplicate elimination will be done, and then only sorting will be done. If it is not a duplicate, then the element will be compared against to the remaining previous elements. So let's consider like we are adding this. Now after adding 50, we are adding 115. So 115 will be compared with 50 as well as 123 as well as 200, and sorting happens. Okay, so whenever we add a new element to a tree set, okay, definitely sorting will happen. Okay. Whenever a new element is being added to a tree set, sorting will happen automatically. Now, let me add some elements which are of type person. I'm adding 5% objects. Okay. Like this I have added 5 elements. Now I am adding 5% objects to the tree set. I am adding 5% objects to the tree set. I am sorting the elements. Now what is the order that is printed in the set? What is the order that is printed in the set? Understood my question? What is the order of elements? Just tell the ideas. What is the first element in the set? Second element in the set? Third, fourth, and fifth. I told that automatically the three set elements will be sorted. Now, if the elements of this tree set, if these person objects are sorted, just tell what is the order they are printed.
By default, passenger objects are non-comparative.
So what happens? It will give a class cast exception. So by default, the tree set expects elements to be comparable. By default, a tree set expects the elements to be comparable, like a collections.sort of list. We can we can compare a normal tree set with a collections.sort of list. It is equivalent. Just the tree set is the same. A normal tree set is the same like collections.sort of list. What the collections.sort of list expect? The collections.sort of list will expect that the elements should be comparable. In the same way, a tree set by default will expect that the elements should be comparable. But is the person class comparable? No. The person class is not comparable. So it will give a class cast exception at the runtime. So it is giving a class cast exception at the runtime. So now by default tree set will expect the elements to be comparable, and by default the collections.sort which takes a list will expect the elements in the list to be comparable. To avoid that, what we are doing? To avoid the usage of comparable, what we are doing? We are using comparator, and which sort method we are using? Collections.sort method which takes a list and comparator. Right? In the same way, we can create a tree set on top of a comparator. How we can create a tree set on the top of a comparator means, while creating a tree set, the tree set constructor is overloaded. Okay? The tree set constructor is overloaded. It can take it can be arguments as well as it can take a comparator. The tree set constructor is overloaded. It can be arguments as well as it can take a comparator. While creating a tree set object itself will specify what is the comparator that we use. While creating a tree set object itself, we specify what is the comparator that we use. So by default, if you use an augmented constructor, then the tree set will expect the elements to be comparable. But if you don't want to go for comparable, if you want to go for comparator, we should give that comparator while creating the tree set object. Okay? We should provide the comparator as an argument. We should provide the comparator as an argument while creating a tree set object. While creating a tree set object, we should give the comparator as an argument. So now the tree set will sort the elements based on the comparator. Now the tree set will sort the elements based on the comparator. Understood? Now it will compile and even execute successfully. So, are the elements sorted in the ascending order of IDs? Okay, is that the comparison logic present in the comparator? To sort the elements in the ascending order of the IDs? Yes. So, the elements are sorted based on the comparator. Understood? How we can use comparator in case of search stream? While creating the tree set of the result, we should provide the comparator as an argument. But in case of list stream, we will provide to the collections.sort method as a second argument. Understood? And now let's consider like we have some elements in the hash set. Okay, I have a hash set. Okay, I have a hash set and I want to sort the elements of a hash set. What I can do? See, to sort the elements of a array list or vector or linked list, what we do is just we go for collections.sort of the list and comparator. But to sort the elements of a hash set, what we need to do? Okay, to sort the elements of a hash set or any set stream, the only possibility is to go for a tree set. To sort the elements of a set stream, the only possibility is to go for a tree set. So, in general, if you want to go for a sorted set, definitely we go for a tree set. But if we have an existing hash set and if you want to sort the elements of a hash set, okay, if we have an existing hash set and if you want to sort the elements of a hash set, then what we do is we push that elements into a tree set. So, see, the constructor of any collection can take any other collection. See, the constructor of set stream collection can take even a list. So, if you are taking a list or a constructor of any collection can take other collection. See how what we are doing while creating a tree set, we are providing a hash set. So, all the elements in the hash set will be pumped into the tree set, or all the elements from the hash set will be pushed into the tree set. Even we can give a list. So, all the elements from this list will be pushed into the tree set. Likewise, while creating a collection, we can give any collection as an input. So, the elements from this collection will be pushed into this collection. So, now elements from the list will be pushed into the tree set. Understood? It's not a rule that it's not like we should create only a set on top of a set. We can create a set on top of a list, or we can create a list on top of a set. Understood? So, it's not specific to a stream. Okay? Let's consider that. It's a basic example that we have a list. Okay, and I'm adding some elements to the list. So I have added 5 elements to the list, and if you want to create a set on top of the list, what we can do is just that's it. So all the elements from this list will be pushed into that set. Okay? That's how it will be. So if you want to create a collection on top of other collection, just there are two possibilities. Okay? While creating the collection itself, we'll give the second collection as the input. Or while creating the collection, if you are not giving the collection as input, what is the other possibility? To add all the elements of list to the set, we can use add all. So we can set dot add all list, so that it will add all the elements from the list to the set. It will push all the elements from the list to the set. Either we can go for a new hash set of this is one option. But while creating the hash set, if we want to add elements, then either we can go for add on. So we can add the elements from a list to a set or a set to a list very easily. Okay? We can add the elements from a list to a set or a set to a list very easily. There are two options. Either we can add the elements while creating the set, or the second option is, if you don't add the elements, then we can go for add-on. It can be even vice versa. If you want to add elements from set to a list also, we use the same. Either while creating the list object, we can give the input as the set, or list.addAll set. Understood? This is how we can add elements from one collection to another collection. So now let me go for a set. Let me go back to the tree set. I have a hash set here. Okay, so I have some elements in the hash set which are not sorted. So if I want to sort the elements of a hash set, the only possibility that I have is to go for a tree set. So let me go for a tree set. New tree set of, what's the thing? Set. Okay. Now what I'll do is, sorted set equal to new tree set of set. So just let me print the sorted set. And before that, let me print the set. First I am printing the set before sorting. Okay? Okay? So I'm clearing the set. Okay? And I'm going for a sorted set. Understood what I've done? Understood what I have done? First, I have a set which represents a hash set, and I have added some elements to a hash set which are not in the order. So what I am doing is I am sending that elements to a tree set, and this sorted set contains the elements in the ascending order. So now I am printing the sorted set, and then what I am doing is I am clearing the base set, and then I am adding the elements from the sorted set to a base set. So I am printing the set. Understood what I have done? Now let us see how the elements are printed. Compile, go to the classes, execute application. Now what it is giving? Class-cast exception. Why it is giving class-cast exception means we have gone for a tree set which is not taking comparator. So we can go for a tree set which is nulls, which will go for comparable. We can go for a tree set which takes a collection, even it goes for comparable. So if you want to give a collection as well as a comparator, okay? If you want to give a comparator, we can give a comparator as an argument. If you want to give both collection as well as a comparator, then the comparator should be as a second argument. So the collection and the comparator. So previously what we have done, if you do like this, what happens? Will it expect to be comparable or will it expect a comparator? If I go for a normal tree set, what happens? Will it expect for comparable or comparator? Comparable. So if I give a comparator, what happens? The tree set elements will be sorted based on comparable or comparator? Comparator. So now if you give a set, a collection, I have given a collection as input to the tree set. Now, will it expect to be comparable or comparator? Comparable. Just because we did not give any comparator as input to the tree set. We have just given a collection as input. We can give both the collection as well as comparator. When we want to give both collection as well as comparator, then comparator should be the second argument. Okay? So now it will be I think it is in the reverse. I don't think it is possible. Yes. The thing is, either we can go for, I'm not sure, let's see. Yes. Either we can go for a tree set which takes a comparator, or we can go for a tree set which takes a collection. So we don't have a tree set object which takes both a comparator as well as a collection. So if we want to go for a comparator, then we cannot add the elements while creating a tree set. We should go for add-on. If you want to go for comparator, then we cannot add the elements while creating a tree set. We should go for definitely add-on. This is the case if you want to go for a comparator. If you want to go for a comparator, then we cannot add the elements while creating the tree set. We should go for add-on method. Just strike off the previous thing that I told. Okay, there is no there is no constructor in the tree set which takes a set and comparator. Okay, there is a method only which takes a comparator or a set. Either we should give a set or a comparator. If we give a set, it will internally make use of comparable. If we want to go for a comparator, we should give a comparator as an argument, and after creating a tree set, we should make use of add-on to add elements from the collections from another collection to a tree set. Okay, understood? So, if you want to go for a comparator, then what we need to do is, we cannot add the elements while creating the tree set. So, if you want to add the elements to the tree set, what we do is, we go for an addl of set. This should be done. Addl should be used if you want to go for a comparator. So, what I am doing is, I am creating a sorted set, okay, on top of a comparator, and then I am adding all the elements from the set to the sorted set, and I am printing the sorted set, and I am clearing the base set, and again I am adding the elements from the sorted to the base set. Okay, so let's see what happens. Now, the first one is the hash set before sorting. First one is hash set before sorting. Okay? The second one is the tree set, the sorted set. Okay? Is the sorted set sorting the elements? Yes or no? Yes. Now the third one is, okay, the hash set after adding the elements. The third one is the hash set after adding the elements from the sorted set. What we have done, just let's compare this. Let's try to compare this. What is the first system.out.println? Hash set. Hash set before sorting the elements. So hash set is giving some in some random order, not in ascending order. Now, what we are doing? We are creating a sorted set based on the comparator. We are adding all the elements from this set to the sorted set. We are adding all the elements from the, we are creating a tree set based on the comparator. Okay, and here we are adding all the elements from the hash set to the tree set, and we are printing the tree set. Then, second thing is we are printing the tree set. Is the tree set printing the elements in the order? Yes or no? Is the tree set printing the elements in the order? Yes, this is in the ascending order of the ID 100, 150, 300, and 400. The tree set is correctly printing. Then again, what we are doing? We are clearing the hash set and we are adding all the elements from the tree set to the hash set. Even if we add all the elements from the tree set to the hash set, is hash set giving any order? Yes or no? No. So we cannot expect any order from the hash set. We cannot expect any order from a hash set. Even if we saw the elements. Even if we saw the elements of a tree set, even if we saw the elements of a hash set using a seated tree set, and even if we add the elements from a tree set to a hash set, again the elements will be in a random order. The elements will not be sorted in a hash set. Okay? Even if we added a sorted set, okay, even if we add a sorted set to a hash set, we cannot guarantee for any order. See, what we are doing is, here we are adding a tree set to adding the elements of a tree set to a set, hash set. So, even if we add elements which are already sorted to a hash set, it's not giving any order. So, we cannot expect any order if we have a hash set. In case of a hash set, we cannot expect any order. So, if we want to go for some order, then we should go for a tree set. Let me make a hash set as a linked hash set. The linked hash set will follow the insertion order. So, even if we want to sort the elements of a linked hash set, we should go for a tree set. But ideally, If you want to go for a set where we need to sort the elements, we should go for a tree set. So, is the linked hash set after adding from the sorted set, is it giving the correct order? Yes or no? Yes, just because the linked hash set will follow the insertion order. Okay? Linked hash set will follow the insertion order. So, from the hash set, from the linked hash set, we are adding the elements to the. From the linked hash set, we are adding the elements to the tree set. First, we have created a linked hash set, and after creating a linked hash set, we are adding some elements to the linked hash set, and we are printing the linked hash set so that it is in the insertion order. It is in the insertion order, but it is not in the ascending order. Am I right? The elements of the linked hash set are in the insertion order, but they are not in the ascending order. So, to sort the elements in the ascending order or descending order, what we do is we provide the elements to the tree set. We add all the elements from the linked hash set to the tree set. So, what the tree set will do means the tree set will sort the elements in the order as per the logic that we give in the comparator. Okay? And then, what it will do? Just I am printing the sorted sort so that they are sorted. And again, what I am doing, I am clearing the linked hash set. And again, I am adding the elements from the linked hash set to adding the elements from the tree set to the linked hash set. If I add the elements from the tree set to the linked hash set, what happens? It will follow the insertion order. Again, linked hash set will follow the insertion order. In which order they will be inserted means in order that they are present in the tree set. In what order they are present in the tree set? Ascending order. So, even the linked hash set also will contain the elements in the ascending order. Understood? Just because linked hash set will follow insertion order. Whatever the order the elements are inserted, linked hash set will follow the same order, which is insertion order. Okay? Understood? So, in these cases, in the cases of sorting, we should go for linked hash set and tree set. But we should not take the hash set. It's very dangerous while sorting. We should not take hash set while sorting. Okay? Understood?
In both the cases, we have to use collection and comparator. We have to use add-on. In both the cases, when we are adding comparator and collection,
if you use comparator and set, definitely we should go for add-on to add the elements of one collection to another collection. Okay? Now, compare the hash set and linked hash set. Now, this is how the sorting happens in case of a set tree by using a tree set. Anyway, if we want a set, okay, if we want a set, okay, anywhere if you want a set to be sorted, ideally you should go for tree set. Let's consider like we need to sort the elements only one time. See, if we take a tree set, there are advantages and disadvantages. If we take a tree set, what happens? Whenever we add elements to a tree set, it will be eliminate the duplicates as well as it will sort the elements. But in some scenarios, it may not be desirable. See, if we have 100 elements in a set that are supposed to be added in a set, we are supposed to add some 100 elements in a set. Okay? While adding each and every element, if we sort the elements, will it give better performance? While adding each and every element, if we try to sort the set, will it give a better performance? Yes or no? No. So, while adding a new element, we need to let's consider like I have 50 elements now. I'm adding 51st element. If I'm adding 51st element, I need to compare the 51st element with the remaining 50 elements, which takes time. So, the tree set will degrade the performance like anything. So, the ideal approach is take a linked hash set first, add all the elements to a linked hash set. So, all the elements will be there in the linked hash set, and then send the elements of the linked hash set to a tree set. Okay? And send back the elements from the tree set to the linked hash set. So, sorting will happen only once. Sorting will happen, in that case, sorting will happen only once. Rather than sorting the elements, whenever we add the elements, okay? take a linked has set to represent a set to eliminate the duplicates. Okay, then add all the elements that we wish to the linked has set. Okay, when we came to know that there we don't add any elements, then pass the elements from the linked has set to a tree set. Then what happens? Tree set will sort the elements. Okay, and just clear the linked has set and pass the elements from the sorted tree set to the linked has set. So, how many times sorting occurs in this process? How many times sorting occurs in this process? Only once. So, this is the ideal approach of using set and sorting the sets. Tree set is a very dangerous thing in case of performance.
But sir, inside the add also we will add one by one the tools.
It will not, we are doing it a single shot. See, we are not comparing each and every element, right? Add-on will not compare each and every element. Just, it will add all the elements from the set to the set. If it is a set, add-on will take a collection. It might be a list or a set or whatever it might be. But if add-on takes a set, if we give a set to add-on, what happens? Set is already already eliminated the duplicates, right? So it will not verify the duplicates again. Set is, if the inputted is a list, obviously it is a problem, just because again it will compare. But if it is a set, what happens? Set is already eliminated with duplicates. So again duplicate elimination will not be done. Okay? So the ideal way is going for a linked set, okay, and add all the elements to the linked set, okay, pass the elements to a tree set, and the tree set will have sorted elements, and clear the linked set and pass the elements from the tree set to a linked set. So this is the ideal approach of sorting. Okay, rather than sorting the elements, okay, whenever we add the elements, this is the ideal approach. And compare the three set classes. Now sorting in case of set stream is completed. Now compare one set class with another set class. First let's compare has set with a linked has set. Just list out the differences between has set and a linked has set. So the first one is just try to sort out the differences between a list and a set. What are the differences between list and a set? Just list out your own differences that you felt and we'll discuss later on. Over? Achal, I have not just started. It's not the way of learning, sir. Now, what's the first difference? List? List is an indexed collection. Okay? The first and foremost thing should be list is a indexed collection. Okay, list has some indexes, but set is not an indexed collection. List is a indexed collection, but set is not an indexed collection. And second should be duplicate elimination. List will not eliminate duplicates, but set will eliminate duplicates based on equals and hash code method. Okay. The elements of a list are stored in continuous memory locations. The elements of a list are stored in continuous memory locations. But elements of a set are not stored in continuous memory locations. There is no guarantee for a set that set elements are stored in continuous memory locations. They may or may not be stored in continuous memory locations. But list as elements are definitely stored in continuous memory locations. Except linked list. Even linked list also stored in continuous memory locations. But has a link, that's it. Even linked list also, the elements are stored in continuous memory locations, but the previous and next element references will be there, that's it. Okay? And the next thing, a list will accept multiple null values, but a set will not accept multiple null values. List will give a far better performance when compared to set. List will give a far better performance when compared to set. Why list will give better performance when compared to set? Why? What is the reason that list gives a better performance, a very better performance when compared to set? Okay, whenever a new element is added to a set, what happens? The new element, okay, will be verified with the existing elements, whether it is a duplicate of existing element. Let's consider like if we have 40 elements, if we are going to add the 41st element, the 41st element will be compared with the remaining 40 elements, whether it is a duplicate of the existing element or not. So, for that reason, when we add a new element, it will degrade the performance. As we go on adding elements to a set, it will degrade the performance. So, if our requirement is not duplicate elimination, if duplicates are allowed, then we should go for a list. If our requirement is if duplicate elimination is not required, then we should go for a list, just because it gives a better performance.
Instead of asset also you cannot give null values, multiple null values.
But multiple null values will exist. Doesn't exist, right? Okay, and the next is iteration. For iteration of a list stream, we can use either iterator or a list iterator. But for iteration of a set stream, we should go for a iterator. Okay, and for sorting the elements of a list stream, we should go for a sort method of the collections class. For sorting the elements of a set stream, we should go for a tree set. And anywhere where we need not to eliminate the duplicates and we should have a better performance, we should go for a list. Okay? Anywhere if we want to eliminate the duplicates, definitely 100% duplicate elimination will be done only with a set. So, if there is a concept of duplicate elimination, definitely the first thing is set. Okay? And duplicate elimination should be there, and if we need not to go for any order, then which one will choose? If duplicate elimination should be there and we need not to go for any order, which one we choose? Asset. If duplicate elimination should be there and if you want to follow some insertion order, declare asset. If duplicate elimination should be there and if you want to go for some sorting, trace it. Okay? And if there is no duplicate elimination but the elements should be sorted, if there is no duplicate elimination but the elements should be sorted, there is no duplicate elimination. There is no requirement for duplicate elimination, but the elements should be sorted. We should go for an array list. We should go for an array list with collections.sort. There is no duplication. We should not use a set at all, just because set will give a list performance. So, if we don't want duplicate elimination, then we should not use set at all. We should use set only when duplicates are supposed to be eliminated. If we don't want duplicate elimination, we should use the list stream. And in the list stream, which one gives better performance means? Obviously which one gives the better performance in list? Array list. Array list is the best performer in the list stream. So, we should go for a array list. Now, if you don't want to eliminate the duplicates, If you don't want to eliminate the duplicates, and the container should be thread safe. See, and one more thing, Prasad, in the previous example you told the vector. Why did you tell the vector? Did you think any reason or? Will? Even array list will allow duplicates. Even linked list will allow duplicates. Why did you tell only vector? Is there any specific reason behind that? Or just because vector is a list? Did you tell just because vector is a list, or did you think that there is a specific reason behind that? Just because, man. Synchronize. Did I ask that the list should be thread safe? No, right? See, if they ask for thread safe, then only we should make it thread safe. Otherwise, unnecessarily, if we make a collection thread safe, what happens? Performance will be degraded like anything. So, if the thread safe activity is mandatory, then only we should make a collection as thread safe. Now, my next question is, okay, if you want to go for a collection where duplicates need not to be eliminated and the collection should be thread safe, which one should be used? Which one should be used? Vector. Just because vector is thread safe by default. Okay? And my next question is, we should go for a collection where duplicates are allowed and there are random insertions and deletions to that collection, and the collection should be thread safe. Just analyze my question. I should go for a collection. Okay? The collection should be, the collection need not to eliminate the duplicates. That's the first thing. The collection need not to eliminate the duplicates. There are random insertions and deletions to the collection. And the collection is thread safe. Then which one I'll go? Which one I'll select? Linked list. But is linked list thread safe? So we should go for a linked list and we should make it synchronized. If we have a random insertions and deletions, definitely we should go for a linked list. But if we want to make it thread safe, what we need to do? We need to go for collections.synchronized list of that linked list. We should, in that case, what we do is we go for a synchronized linked list, not a vector. Just because thread safe, we should not go for a vector, because we have another requirement that we should have random insertions and random deletions. So if we have random insertions and deletions, we should go for a linked list. But if we want to make even thread safe, we can make a linked list a thread safe. But can we make a vector to have random insertions and random deletions with better performance? No. So we can make a linked list as thread safe. So it's a better option to make a synchronized linked list for this purpose. Understand? We cannot tell this collection is best and this collection is worst. Every collection is used based on the requirement, based on the business requirements. Okay? If you want to have a collection which eliminates the duplicates and which gives you better performance, definitely we should go for hash set. Linked hash set will give you less performance when compared to hash set, just because it has the links, it has the references of the previous and the next element, which is an additional effort. But hash set, it will give the best performance in the set stream. But did I tell that it should follow some order? In the previous question, did I tell that we should follow some order? No. What my question is, okay, we should have duplicate elimination and it should be better performing. So in that case, we should go for hash set. If you want to go for duplicate elimination as well as sorting, tree set. So any collection should be used based on its requirement. Okay? Now compare hash set and linked hash set. Write down the differences between hazard and linked hazard. And even write down the differences between hazard and reset. And hazard and linked hazard and reset. Now write down the differences between first hazard, linked hazard, reset, hazard and reset. Those three. Just I'll give 5 minutes. First list out the differences of hazard and linked hazard. Then list out the differences between linked hazard and reset. Then list out the differences between hazard and reset. I'll give you 5 minutes. Okay? Oh, now what are the differences between has set and linked has set? Has set? Order. In case of linked has set, we can expect a insertion order. Has set doesn't contain the references to previous and next elements, but the linked has set will contain references to previous as well as next elements. Like the difference between array list and a linked list. Array list doesn't contain the references to previous and next elements, but linked list contains. In the same way, has set doesn't contain the references to previous and next elements, but the linked has set contains the references to previous and next elements. And the next thing is performance. Has set will give a far better performance when compared to linked has set. Okay, and the next one, linked has set and tree set. What are the differences? What is the first one? The linked has set will allow null values, but that should not be the very first difference. The very first difference is the elements of the linked has set are not sorted. Okay, the elements of a tree set are sorted. That should be the first difference. The first difference is sorting, right, between linked has set and tree set. The elements of a linked has set are not sorted by default, but the elements of a tree set are sorted by default. And the second thing is, we can add non-comparable elements to a linked has set, but we cannot add non-comparable elements to a tree set. We can add non-comparable elements to a linked has set, but we cannot add non-comparable elements to a tree set. Okay, and the next thing is null. Linked has set will allow null values, but tree set will not allow null values. And which one is a better performer? Linked has set or tree set? Linked has set is a better performer. And can we tell the same differences for has set and a tree set? Can we tell the same differences for has set and tree set? Yes, except the order. Has set will not give any order, tree set will give a sorted order. Except the difference, all the difference between linked has set and tree set are the same. The same differences between linked has set and tree set will be for has set and tree set. Except has set will not give order, but tree set will give insertion order. And is a set thread safe by default. If some interviewer asks you this question, then the answer should be no. A set is not thread safe by default. Is a list synchronized by default? Is a list synchronized by default? We should not tell no. Only vector is synchronized in the list. Linked list and array list are not synchronized. But all the classes in a set are not synchronized by default. All the classes in a set are not synchronized by default. They are not thread safe by default. They are hash set or linked hash set or tree set. They are not thread safe by default. A set stream is not thread safe by default. Then, to make a set as thread safe, we should go for collections dot synchronized set. Like a synchronized list, we have even a synchronized set method also. If we want to go for a thread safe set, then we should pass that set to a synchronized set. All the set classes are not thread safe by default. Okay? So, to synchronize or to make a set as thread safe, we go for a method synchronized set. Okay? We go for a method synchronized set of collections class to make a set as thread safe. Collections.synchronized set method is used to make a set as thread safe. Understood? So, learn the collections comparatively. Why this collection is used? In which scenario I should use this collection? When a array should be used? When a vector should be used? Okay, when a linked list should be used? And when a hash set, linked hash set, tree set. Each and every collection has its own advantages and disadvantages. So, based on the business requirement, we should go for a specific collection. We cannot tell this is best and this is worst. It depends upon the scenario. For this scenario, which one is best and which one is worst? Okay? Comparison and evaluation of a best collection will depend upon the situation, scenario. Okay? And let's wind up for the day. And in the next session, we will discuss about the map stream. List and set are completed. Okay? In the next session, we will discuss about the map stream. Next session will be as it is evening 8:30. Okay?